why they go from dose to risk, from root to sign. We learn the body line by line. Porphyra, the father's name, modern toxicology gave him fame. He studied poison, organ by organ, forensic science started growing. Xenobiotic means foreign to life, from Greek words with a stranger vibe. As it means it can cause harm, risk needs exposure to raise alarm. Plutonium may be hazardous, yes, but sealed away. The risk is less when exposure rises, risk can grow. That is the point we need to know. The dose makes the poison, that is the golden line. Too little, too much, can change the body sign. What is life? But too much can be wrong. So learn and sing this toxic song. Inhalation works very fast, seconds to minutes it does not last. Thin lung walls and blood supply help substances quickly fly. All root goes through the liver, first pass metabolism may deliver. Let's bioavailability in the blood before it reaches where it should. A is absorption, it enters in. D is distribution, spread within. M is metabolism, liver's role. E is excretion, out it goes. The dose makes the poison, that is the golden line. Too little, too much, can change the body sign. What gives life, but too much can be wrong. So learn the dose and sing this toxic song. Bioactivation can change a thing to a toxic form that harm may bring. Paracetamol can form NAPQI when the safe pathway runs too dry. Phase 1 changes with oxidation, reduction, and hydrolysis transformation. Phase 2 joins and makes it clear. Water soluble out from here. Organophosphate block the enzyme. Acetylcholinesterase, remember the line. Acetylcholine left in place. Cholinergic crisis can show its face. Dose makes the poison, that is the golden line. Too little, too much, can change the body sign. The half-day diet that's given, low number means more toxic, that is how the fact is written. Cyanide plus 4.4 mitochondria work no more. Electron transport cannot flow. Energy production becomes lower. Substance A is stronger here. 0.01 makes that clear. Substance B needs much more dose, so A is toxic. Keep it close. TI means the safety space between helpful and harmful place. Time needs careful care. The toxin danger may be there. Newborn babies are at risk. Young liver enzymes may be weak. Elderly people are at risk too. Kidneys may not clear like they used to. NEC help paracetamol cases restores to passion in body spaces. Death within 8 hours time. Early treatment works just fine. The dose makes the poison. That is the golden line. Too little, too much, can change the body sign. What's at risk? ADME is to chemistry. So you will see toxicology makes me. Porphyra, Xenobiotic, positive risk and dose, ADME and antidotes. That is how toxicology flows. What dose makes the poison? That's the golden line. Too little, too much, can change the body sign. Honor gives life, but too much can be wrong. So learn the dose and sing this toxic song. Inhalation works very fast, seconds to minutes, it does not Thin lung walls and blood supply help substances quickly fly. Oral route goes through the liver. First pass metabolism may deliver less bioavailability in the blood before it reaches where it should. A is absorption, it enters in. D is distribution, spread within. M is metabolism, liver growth. E is excretion, out it goes. Don't mix the poison, that is a golden line. Too little, too much can change the body sign. Move it, change it, clear it away. Toxicology helps us see how chemicals act each day. Bioactivation can change a thing to a toxic form that harm may bring. Paracetamol can form NAPQI when the safe pathway runs too dry. Phase 1 changes with oxidation, reduction in hydrolysis, transformation. Phase 2 joins and makes it clear water soluble out from here. Organ the phosphate, block the enzyme. Acetylcholinesterase, remember the line. Acetylcholine, arrows in place, cholinergic crisis can show its face. The dose makes the poison, that's the golden line. Too little, too much can change the body's sign. The LD50 half may die, that don't give me lower number means more toxic. That is how the fact is written. Cyanide blocks conflicts for mitochondria work no more. Electron transport cannot flow. Energy production becomes low. Substance A is stronger here. 0.01 makes that clear. Substance B needs much more dose. So A is toxic. Keep it close. CI means the safety space between helpful and harmful place. Narrow TI needs careful care. Digoxin danger may be there. Newborn babies are at risk. Young liver enzymes may be weak. Elderly people are at risk too. Kidneys may not clear like they used to. NAC helps paracetamol cases, restores glutathione in body spaces. Best within 8 hours time. Early treatment works just fine. That's the golden line. Too little, too much. And change the body size and risk ADME. Phase 1, phase 2 chemistry. Learn the song and you will see toxicology. Xenobiotic, hazard, risk, and dose. ADME and antidotes. That is how toxicology flows. Toxicology, let us know how poisons move and where they go. From dose to risk, from root to sign, we learn the body line by line. Orfila is the father's name. Modern toxicology gave him fame. He studied poison, organ by organ. Forensic science started growing. Xenobiotic means foreign to life, from Greek words with a stranger vibe. Hazard means it can cause harm. Risk means exposure to raise alarm. Plutonium may be hazardous, yes, but sealed away the risk is less. When exposure rises, risk can grow. That is the point we need to know. The dose makes the poison. That is the golden line. Too little, too much can change the body. Toxicology, let us know how poisons move and where they go. From dose to risk, from root to sign, we learn the body line by line. Orfila is the father's name. Modern toxicology gave him fame. He studied poison organ by organ. Forensic science started growing. Xenobiotic means foreign to life, from Greek words with a stranger vibe. Hazard means it can cause harm. Risk means exposure to raise alarm. Plutonium may be hazardous, yes, but sealed away. The risk is less when exposure rises. The risk can grow. That is the point we need. So, good evening, everyone. Um, we are already displaying the lecture questions, which is going to be like 10 objective questions. Please be very fast with the question, then you submit in the comment section. So, thank you. This is the fifth question. I have like 4 more questions to go. Don't forget to submit the correct answers in the comment section for both pre and post. The post questions is going to be in form of essay questions, and that's why it is going to take like 15-20 minutes for me to display them. And by the grace of God, I am going to get it collected. That is, you have to submit it by tomorrow when we'll be having bioinformatics lecture. You are expected to submit physically. Question 7. If a substance has no observed adverse effects, that is NOAEL of 100 milligram per kilogram, what will be its calculated acceptable daily intake? Don't forget that the pre-test or the pre-lectures is just to gather your knowledge about it. You might not actually need to get 100%. Even if you are getting 0% for pre-test, the most important is what you are going to get immediately during the post-test. That is very, very important. Why are neonates, that is newborn, often more susceptible to toxic insults than adults? You have to pick the correct options. So once again, this is the voice of Adeotola Michael of EduInteractAI. Don't forget that today, this is toxicology. This is going to be the third lectures on toxicology. And just like you know very well, and what you are conversant with, I am going to display, okay? I'm going to first of all start with the infographics. And from that infographics, that's when I'm going to begin and explain some basic terms and terminologies, or what is going to be the content of what we are going to present today. Infographics is going to be like the summarized pictorial version of the whole lecture. And today's title of the infographic is titled Understanding the Science of Poison. I told you that toxicology means the science of poison, and it's going to be the foundational overview of toxicology. That is, if you want to look at what's going to be the basic content of the presentation or the lecture, it is going to be involve the core principles of toxicology, the biological processes, that is the mechanism, how a poison is being processed within the body. Okay, then apart from that, we will also look at the toxicity measurement. That is, if you want to know the amount of dosage, don't forget that poison will actually depend on the dose, and that is what Paracelsus introduced in the field of toxicology. That is, the dose makes the poison, if even no matter how risky or harmful a substance could be, it depends on the dosage that gets into your system. If it is not up to the dose that can cause any damage, that means it is not yet a poison. At that level, it is also going to be like a remedy. So the difference between a poison and remedy is the amount. For example, water is very good and is always very useful to be used as a remedy. But when it is getting into certain dosage, that is when it is going to become a poison. So in this presentation today, we are going to look at hazard versus risk. What do we mean by hazard? The hazard is the internal harm potential, the capability or the potentiality of any harm. If you pick up any substance, what are inherent in that substance to be regarded as an hazardous content, we'll look at it, and that is what is called hazard. So some of us might find it not too easy to be able to differentiate between the risk and the hazard. So, and that is that. So when you look at this, you will see that this is a substance that is contained in a container, and that is the intrinsic harm potential. You are looking at the potentiality or the probability of
a substance being regarded as an hazard. So when you are looking at the risk is going to tell you the probability that a certain substance is going to cause any harm during specific exposure, and that is a risk. So if somebody asks you to differentiate between hazard and risk, you should be able to know that hazard is talking about that means the harm is not yet uh, done, not yet being perpetrated. It is still a potential. So, but when we are talking of the risk is like the probability that it is going to cause, that any specific substance is going to cause during a specific exposure period. Then the foundational principle that you must know in toxicology is that the dose, the poison depend on on certain dose. That is, toxicity is determined by dose, determined by the duration and the route of entry, not just the substance. There are certain times that food is very good, and that food, in terms of the dose, it might just be very, very small. And if you take it in the right, if it follow the right route of entry in form of absorption, for example, if you want to take well prepared fried rice now, and it is in very small quantity, and you are not taking it through the oral, that is not through the mouth, and you want to take it by another route, maybe you want to sniff it, what you're supposed to take through the mouth, you want to start taking it through another route, so it is going to be so poisonous. That's why um, the toxicity of any substance will not only depend on the dose, it will also depend on the duration of exposure, and it also depend on the route of entry. So another thing we will also look at in today's lecture is going to be the difference between toxin and toxicant. These two are very, very synonymous, but they are very different. When we are talking toxicokinetics, kinetics will, whenever kinetics is coming into the play, you know it's going to talk of motion, it's going to talk about movement. That is, the toxicokinesis is what is involved when we are talking about absorption through the mouth, how it is the substance is um being distributed in the body. Then apart from that, what is going to be the metabolism? How is it going to be, such substance is going to be metabolized in the liver, for example, then how is it going to be excreted? So toxicokinetics will be talking about absorption, which is A is standing for absorption, D is standing for distribution, M is standing for the metabolism, or what we can call biotransformation. Then the E is standing for how it is being excreted, that is the removal of that substance from the body. Is also very, very important. And for you to be able to know very well, anytime we are talking of toxicokinetics, because it is kinetics. Kinetics means the movement, that is the movement of any substance, toxic substance, right away from when it is absorbed to the last level of, that is the journey, talking about the journey, movement from the um, movement from certain points, that is a point where that substance is taken off to the last destination, to the last bus stop, which is excretion. That is the biological movement and the biological processing and measurement of uh, toxic substances. Then anytime we now come across the second movement, or the biological process, is a toxicokinetics. That is how does harm occurs. So for example, is it going to be in form of enzyme inhibition? Is it going to involve oxidative stress? Is it going to have effect on the DNA, or it's going to have the effect on the cell membrane, and so to say? And that is toxicodynamics. Don't forget, we talk about dynamics or dynamism. That is talking about the mechanism of change. So that's why we said toxicodynamics involve chemicals that cause damage via enzyme inhibition. It could be via enzyme inhibition, oxidative stress, DNA damage, or it can be by uh, membrane disruption. Then the last aspect we will also talk about in this presentation is the measurements. How can we measure the amount of toxin or the amount of chemicals? So, and that is that. So the first one we'll talk about is the LD5. LD means leader dose 50. So LD50 means the dose to kill 50% of the test population. For example, if you have a chemical A, and in that chemical A, you want to test the effect on 100 rats. For example, uh, the dose that is going to be so sufficient to eradicate or to have an harmful effect on 50 out of that 100 is called the LD50. So that is that. So when you put the toxin or you put the substance, the risk of that substance, when you weigh it on a scale, that means the rate of 50 that is going to be leather, is going to be hazardous to 50% of that population is called the LD50. Then we will also look at what is super toxic, for example, and very, very toxic, and slightly toxic. We'll also look at that in this presentation or this lecture today. So I want you to follow me as I go into the lecture per se. Don't forget that this is just the infographics. Info is the information, and graphic is from the graphical representation of my lecture today. So that is going to be what. So let's go to the presentation of this. So that is going to be this one. Okay. Okay. So toxicokinesis or toxicology, introduction to toxicology. Okay. And that's why I'm going to title this presentation. I'm going to title it The Science of Poisoning. That I've told you, toxicology means the science of poisoning. Uh, Anytime you come across toxicology, you can call it the science of poisoning, science of hazard, and the science of poisonous effects on earth. So don't forget once again that this is a EduInteractAI Digital Hub, and this is the voice of Adil Solatunde. Okay. Now, when you look at what actually dictates that a certain substance is going to be poisonous, or can be regarded as toxic, or can be regarded as poison, will actually depend on the amounts, on the dose. Don't forget that according to Paracelsus, who lived between 1493 and 1541, which I have been telling you that the father of toxicology is Paracelsus. So he was the one that also introduced that the dose dictates the poison. So, and this phrase, the dose dictates the poison, means that all substances are poisons. Why all substances are poison means that none, every substance is a poison, but it is not going to be a poison if it is taken in the right dosage. So, and that's why Paracelsus said the differentiation of a poison from a remedy is in the dose. Now, let us look at the first example. that is water. Water is very, 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 very good. And we all, in fact, 97% of the body of human is uh, contain water. In fact, 97% of our blood is water because we need. No life can survive without water. Okay? And if it is in massive volume, it's going to serve as a remedy. That is a dose. That is, if it is taken in the right volume. For example, every day there are permissible amounts of water that is supposed to be taken. Okay, you know that. Now, for you to regard water as poisonous or the leather dose of water, that means you must take water in excess, and that very excess, that means is going to trigger cerebral oedema. Oedema means swelling, swelling of the brain. So if you take too much water, it's going to lead to excessive water content in the brain. So that is the effects. So that means this level, that's why you have it in a very in this color. But when you have it here, that means it is the other color. That means it is already regarded as a poison. Now, paracetamol is very safe to take paracetamol, and paracetamol, it is used as an analgesic, that is pain reliever. And daily, if you take paracetamol between 500 milligram and 1 gram, 500 milligram means a tablet, and 1 gram means you are taking two. And every day there are permissible uh, dose of paracetamol. Every day, according to WHO, it must not be more than 2 gram per day. And if you take it more than 501 gram per dose, if you take it more than that, it's going to be regarded as overdose, and it's going to have effect on the liver, and it's going to trigger a condition that is known as a hepatic necrosis. So that is that. Then the next one, don't forget that water is natural. This one, paracetamol, is natural, is a chemical. So this paracetamol is synthetic, is man-made, is man-made. So botulinum, this one is a toxin. Toxin, don't forget when I was talking about the differences between a toxin and a toxicant. Toxin means it is coming from natural source like botulinum. And if it is taken in nanogram, that is a very small quantity, you need to take certain amount. You can use certain amount of this toxin to be able, you can use it as a medicine. But if it exceed 1 nanogram per kg, don't forget that the average weight of human is around 60 kg. That means if you are taking in excess botulinum more than that, that is when it's going to be regarded as a toxin or poison. Okay. Now, looking at the history of toxicology, so it can be divided into 4 different eras. The first era is the ancient era, and that was the area of execution and warfare. That was when they started making use of poison from natural sources, from plants, from, don't forget that biblical story that talk about there was death in the pot, that the sons of the prophet had to invite the prophet. I think that was Elijah, that there was death in the pot, and they said, bring me some salt. So what I'm trying to say at this level is that the first ancient era of toxicology was when um, it was used as execution and warfare. Sometimes in those days, they normally use it as to execute instead of using execution by firing squads, instead of using execution by maybe by hanging. Then it was natural source. So that was the first era, ancient era. And in the era of 16th century, that was when there was a paradigm shift. According to Paracelsus, which is regarded as the father of toxicology up to today, that was when he established that those determine the toxicity. He was the one that started laying the philosophical foundation of toxicology, and that was when he introduced that poison depends on the dose, it depends on the duration of exposure, and also depend on the routes of injection, the routes of okay. Then in the 19th century, that was when forensic, that is toxicology, was now introduced in the area of forensic science. So, and it was Matthew Ophila, I have mentioned this, that he is now being regarded as the father of modern toxicology because he was the one that introduced forensic science into the era, I mean, into the era of toxicology. Now, from 20th century to the modern age, and that was when thalidomide disaster and that of Minamata diseases and DDT was known to have great impact on the on human population, and that was when they started establishing a kind of regulatory agencies that will moderate the amount of toxin that is supposed to be allowed. So there are certain chemicals that are banned, completely banned from countries to country. An example is that of a DDT. I am very sure that DDT was banned in the United States since the 1950 in the 1950s. Although we are still making use of that in Nigeria up to today, but when we have that was when the area of regulation, that is certain that was when they introduced EPA, that is Environmental Protection Agencies, and some other agencies like that. That those agencies, regulatory agencies, were solely meant to be able to regulate the amount of toxin or the amount of chemicals that is tolerable. For example, if you are talking of lead, for example, lead has its own tolerable quantity according to WHO and some other regulatory agencies and all this one. So that is why we said you can historically you can divide the era of toxicology into four. The first era is known as the ancient era. That was the era of execution and warfare. Then in the 16th century, that was when there was a paradigm shift. That was when toxicology was regarded as a philosophy. It was a branch of philosophy. And that was introduced by a man called Paracelsus. And that was when he told us that the difference between a poison and a remedy depend on the poison, I mean, on the dose taken. And in the era of Matthew Ophila, and that is being regarded as the father of modern toxicology up to today. So that was when they started picking up certain organs to be used in forensic science. Okay, that was when forensic science was now being introduced. And from the 20th century to the modern era, that was when they started thinking about the certain agencies that could regulate the amount of chemicals, the amount of uh, substances to be taken by. And I gave you an example of that. We are still going to see some of them later on. Now, how can we now categorize poisoning? Poison is regarded as a substance that cause or can cause injury, that can cause illness, or can cause death. That is the definition of poison. Now, poison or chemicals can be categorized. Toxicants can be categorized or classified depending on whether they cause injury, that is, in terms of their impacts, whether they cause injury, whether they cause illness, or whether they cause what is known as death. And that is when it is going to be regarded as a poison. And that's when uh, we can differentiate between chronic and acute. So if you are talking about chronic, we are talking about, or we are talking about chronic or acute, that means we are trying to look at how we can classify poison in form of their impacts. Is it going to cause injury? Is the injury going to be permanent, or is going to be for a short term? And that is it as a result of injury, illness, or death? Then we can also categorize them, poison or substance, in form of whether they are foreign, whether the chemical is foreign. And if it is that, we will talk about xenobiotic. Xeno means foreign, and biotic means life. So any chemical substance which is foreign to the biological system is known as a xenobiotic. And when we have venom, a venom is a toxin that is actively injected via a bite, sting, or spine. And that one is very common in snake. Toxin, I told you that toxin is having the source from a biological agent or natural agent, which could be from plants, from animal, or from microorganism. Okay. Then the last one, which is a toxicant, that means it is man-made chemical or that can cause toxic effect. So you can also classify poison into whether it is active or it is a passive exposure. If it is active, that is a venom. If it is in form of a passive, that is a toxin. And all this, you can also classify poison into either of biological origin or from a synthetic origin. So all these are part of what is expected for you to be able to know how you can categorize certain chemicals that cause injury, illness, or death to living organism. Then once again, if you want to now, I told you that in this lecture, there is every point, every reason for us to be able to know the difference between an hazard and a risk. An hazard is a property, whereas a risk is a probability. So both of them, regard them or know them in form of their P. Hazard is standing for property or the potential, whereas the risk is talking about the probability. So if you look at this compound, plutonium rod, it is very, very hazardous, but it is already contained inside a container. So it is intrinsic. But now when you now expose it, the seal fault, now when you now expose it, that is when it is going to become a risk. So when it is at this level, it is still going to be as a potential. It is the potential. So toxicity is the degree of harm. Exposure is the contact. You cannot talk of exposure if it has not actually had a contact with you. For example, no matter how hazardous, how risky a substance could be, if it has not actually have a contact with you, either you inhaling it or it's coming as a result of a dermal exposure, you cannot in any way talk about it being you being exposed. You cannot at that point. Then without exposure, even the highest risk, just like I said, we pose no risk at all. I've just told you. So it is when you are now having contact with it, that is when the risk can begin, and that is when it can be regarded as toxic to you or as a poison. Okay? Now, what are the branches of toxicity or toxicology? Branches. Number one, if it's going to have the study of the reproductive effect when it is example of teratogenesis and filter impact. If you are trying to look at what is going to be the impact on the reproductive organs. For example, when you are trying to look at the toxicity of paracetamol on reproductive organ in male rats, that means you'll be talking about testes. In female, you'll be talking about ovary. Then if you want to know the impact, that is when after they must have given birth. So that is reproductive. Okay. Then neurotoxicology. Neuro, that means you are trying to look at the effect from the angle of what is going to be the effect on their central nervous system. Then ecotoxicology, that is when you'll be looking at their effect on the food chain. Okay, and part of the regulatory agencies that I actually talk about as the last era of toxicology, which is from 28th century till now. That is when regulatory agencies are now being introduced, like NAFDAC and like WHO. Now, clinical is that you are trying to look at the effect of overdose of certain drugs. Effect of overdose on certain drugs. And we are talking about forensic toxicology. That's when you are now looking at maybe somebody must have died as a result of certain poison or not. That is forensic science. And that was where I said it was a Matthew Ophila that introduced that. Okay. And the environmental, that is the effects of heavy metal contamination on the ecosystem. And that's very, very possible. That's very common in Niger Delta area, where you have uh, gas flaring, and some others. Okay, that is environmental. And toxicology can also come in form of occupational hazard. You are trying to look at the effect of pesticide exposure among farmers. So you see, farm workers, they will normally make use of pesticide, herbicide, and some others to be able to function. So if you are looking at what's going to be the health risk of, for example, in teachers, among teachers, you can decide that you want to look at the effects of chalk inhalation among 25 teachers in Obande Secondary School. That is, you are trying to look at the occupational effect, or you want to look at the effect, what could be the effect of lead or among minors. So that is talking about the occupational. Now, what you're supposed to know is a branching of biological fortress. For example, inhalation. So we won't talk much about it, but I want you to know anytime you come across the word inhalation, that means it's coming through the nose. Anytime you look at a parentera, that means it is very, very essential, like a venom. So that is sudden. So oral, that is injection. Then ocular, that is through what? Conjunctivitis, that is conjunctiva, that is the one that involve eye. It could be derma, that is anything that has to come as a result of it's very slow, very, very slow. So for example, if you want to talk about the effects, okay, effect of certain chemicals, and you just want, how will you expose them? Are you going to expose them as a result of what? Inhaling it. That means you place rats and you allow them to inhale it, and you start now measuring the effect. Or you can use parenteral. Parenteral now means in form of injection, and when you are injecting it, you are injecting it directly into the what? Into the lining, that is GIT. Then oral is talking about coming through the mouth. Okay. Then ocular is as a result of what? Plus, that is the one that involve the eye. Derma has to do with the skin, and transplacental, that has to do with anything reproductive. Okay. So I have also told you about ADME, that is ADME. So that is toxicokinetics. You are trying to look at the journey. You want to look at the journey starting from the starting point where it is inhaled. So then that is absorption level down to when it is leaving the system. Okay, I have a very short period, I mean, very short time, so that I'll be able to display the um, post lecture test, which I told you is going to be essay format. Okay, now the metabolism, paradox, and bioactivation, we will also look at this in some other time. Now let's look at the cellular maps of toxicodynamics. I told you there is difference between toxicokinetics and toxicodynamics. Toxicokinetics has to do with movement, it has to do with journey, it has to do with motion. So, and that is what is called ADME. That is, A is standing for absorption, D is standing for distribution. When it has gotten into the liver, how is it spreading? That is distribution. Okay. Then the next one is a metabolism. That is ADME, metabolism. How is it going to be metabolized uh, in the body? Is it going to be converted? For example, the form of any substance when you are swallowing it is going to be too different from the form it is going to take when it is going to be distributed round the body. So that is admin. Now, the cellular toxicodynamics. This time around, we are looking at dynamism, the structure. Okay, so that's why this one is trying to use the structure of a cell to be able to explain. So this is mitochondria. What are the examples of compound or substance that have their toxicity effects on mitochondria? Example is cyanide. Cyanide, like the one we have from cassava, okay, is going to have direct impact on the mitochondria. And there are some that we have their effects on the cell membrane by disrupting the cell membrane, the composition of the cell membrane, thereby preventing the cell membrane or having direct effect on the cell membrane, which could be as a result of a leakage or leakages. Okay, that is that. So dynamism is actually toxicodynamics is actually talking about the impacts, the change, the mechanism. So that is that. That is enzyme inhibition. For example, like organophosphate, which inhibit acetylcholinesterase. So this has to do with the brain. This acetylcholinesterase is very, very important in what? In neuron or in central nervous system. Okay, that means it is going to have an example on acetylcholinesterase. That means it's going to have the effect on synapses. So we will see all this whenever we also continue. Then as we continue, endoplasmic reticulum, it could be that it's going to have effect on the endoplasmic reticulum, and there are some that they will have effect on receptor, which is going to be in form of agonism or antagonism. Agonism, that means it is helping, it is helping. And when you talk about antagonism, that is the side effect. That is, you are talking about the two-way. That is, as one is decreasing, as one is increasing, it's having a direct effect on the second. Then nucleus can have effect on nucleus. That, for example, genotoxicity, the one that is going to have effect on DNA. That means the toxicodynamics is going to be there. Then this is a universal curve of toxic response. We won't be able to go far on this because there's going to be a certain topic. I think it's going to be our next topic, where we will be talking about this kind of curve. That is a dose response. That is a dose response relationship. So, but at this point, you should know that when there is a substance, it is actually starting from zero in terms of concentration. It's going to have no effect until it gets to this level. And from this level, it's going to take off like this and also continue until it reaches the plateau region and so on and so forth. We will talk about this the more. Okay. So without wasting our time, let's go to the post test, post lecture test. Don't forget what we have said today. Um, okay, the dose determine whether a substance is going to be regarded as a poison or is going to be regarded as a remedy. Okay, they look at water, we look at paracetamol, botulinum, based on their dose. Okay, at a certain dose, it will be regarded as e go to cause excessive edema in the brain. And at a point in time, paracetamol will cause hepatic necrosis. And at a point in time, the botulinum is going to cause certain disease. So we also look at 4 different areas that we have in toxicology. Ancient, the paradigm shift, that is a philosophical stage where Paracelsus established this, and Matthiophylla also introduced um, forensic science in toxicology. So then the era in which we are now is the era of regulatory, modern regulation. Okay. And we also look at how can we categorize a chemical agent of causing any harm. It can be categorized in form of poison. That is, it can cause injury. Sometimes it cause injury, it can cause illness or death. So then you also talk about venom, toxin, toxicant. I said the difference between a toxin and toxicant is that a toxin is natural and is being produced by a living organism. It can be in form of from plants, can be from animals, it can be from microorganisms as well. Then when we talk about toxicant, that is a man-made chemical uh, that is causing. So that means it is coming from uh, chemicals. Okay. But I say when you come across the word xeno means foreign and like that. And I said, what do we mean by exposure? Exposure means that uh, there must be a contact. If there's no contact, the risk, we cannot really measure the risk until there is contact. You should be able to know that. So we also talk about certain branches. I think we have 8 branches of toxicology. The first one, ecotoxicity, regulatory, neurotoxicity, forensic, and so on and so forth. And I also talk about the breaching of the biological fortress, which can come in form of inhalation, parenteral, that is through injection, and when you come across oral, that is um, injection. There are difference between injection and ingestion. Injection is oral, and ocular, that is eye. derma, that is skin, and transplacental, that means it has to come through the reproductive system. So then I also talked about toxicokinetics. Kinetics has to do with journey. Kinetics has to do with movement, and it has to be from absorption right to the time that certain that substance is already living, is on is exit route. Okay, then we also look at okay, this one I did not actually made mention of this, but you should know that we will talk about this the other time. I mean, the next time we will be meeting, and that is when we'll concentrate at cytochrome P450, what could be the effects, and so on. Then we also talk about toxicodynamics, and that's to do with the effect on this. So, without wasting our time, I want to go straight into the uh, question. Okay, into the question. And this time around, it is going to be displayed. So I said there's going to be um, 15 questions, essay questions. You have to do it, just jot it down, and you do it in a sheet of paper, well packaged paper, and you will submit tomorrow physically. Okay, this one is section A, which has to do with the historical and basic concept of toxicology. So, who is known as father of modern toxicology? What I'm actually expecting you to do here is just to take your pen and paper, just write down the question, then later on, and do it religiously, do it diligently, do it very in a very neat sheet of paper, and so that you go and do it and bring it tomorrow. Okay, so that is the question. Is being displayed. It's going to be displayed for just a few minutes. We have section A to D. Section A to D. Okay, please copy the question down. Write the question down. So don't forget that bioinformatics lectures continues tomorrow. That's going to be the week 4. So, and that is when you are going to submit, when it is expected that you submit solution to this question. Okay, yeah, let's go to section B. Okay, maybe let me display it well from let me display it well here so that you'll be able to know it. Sorry. Mm-hmm. You can see this is question 1 to 4. That's section A. So let me switch to question section B. This section B. Just write it down. Route of entry and toxicokinetics. Okay. Okay, let's just make it only section A and B. So that, that means you have only 10 questions. 10 questions. Section A and B. So copy section B and You have 2 minutes to copy that. So once again, I want to sincerely thank you for your audience today. I wish to see you in my subsequent videos and educational, yes, in other educational content. Don't forget to visit our website at EduInteractAI.org for more information. So don't forget to make use of the EduInteract chatbot. So when you get to the website, you can ask our chatbot, ask it any question that is related to science, especially to that is related to any of EduInteract AI contents. So, and it's going to give you answer for that. Once again, I sincerely want to appreciate you, and I will be hoping to meet you in the other subsequent video contents. So don't forget to submit tomorrow. Don't forget to make comments in the comment section.